Welcome to mathematics class. In this video, I'll be explaining the laws of indices. But before that, let me briefly explain something. Suppose you actually want to repeat a variable in let me just say, you want to repeat a variable in, 100 more times exactly. Let's say you are given a variable a, and you're asked to rewrite this variable in 100 times. You'll be saying a multiplied by a, multiplied by a, multiplied by a, right? All to what? To a at what? As n times. Where n is equal to what? 100, right? So what actually happens is that instead of wasting your time and writing this value, it's actually very long, you can simply represent it as what? As a raised power 100. Suppose you are given a times a times a times a times a, and you don't want to repeat this, you can simply say this is actually a raised power of what? 1, 2, 3, 4. 4. You representing this variable in this form, that means you are practicing a notation. This actually represents a notation. It's a notation for indices. And if you're talking about notation, it's actually a short form of writing this expression. Thus, it is known as notation, right? So it has to do with three things, right? The first one is that if you have something like a raised power 4, that means we are dealing with three things. The first thing we are doing is actually here, in this case, our 4 is going to what? To be the power, right? You can call it this 4, you can call it power, or you call it index, or you simply say you call it exponent. It's also known as exponent, right? So that's just it. And another thing here is that we have this a. This a is taken to be the what? The base, right? So as far as notation is concerned, we have two things to consider. Is that you call it a is a base and your 4 is what? Is a power, or you say a is a base and this 4 is taken to be index or exponent. So that's just it about notation. Just now, notation is what? Is the short form of writing an expression. Now, let's move to the laws of indices. Now, the first law. Now, as far as the first law is concerned, now the first law is that, let's say we have a multiplied by what? By a. And the power of this base a is raised to the power of m, and this power of this base a is also raised to the power of n. Then this is actually equals to what? This is going to give us a raised to the power of what? M plus n. So whenever we have an expression, whenever we have an algebra expression in which they have the same base but different power, but they are multiplying each other, then we are going to have to what? A raised to the power m plus n. Suppose we have this what? A raised to the power 4, then multiply a raised to the power 5. This is going to be what? A raised to the power 4 plus 5, which is simply a raised to the power 9. Right? So let's say you have something like this. Let's say you have a raised to the power 4 multiplied by what? B raised to the power 4. What's going to be? Is it going to be a raised to the power b raised to the power 8? No. You cannot multiply these two together. Why? Since both of them are carrying what? Different base. They are carrying different base. So they will be like this. They will remain like this. Their base are not equal. Alright, that's just it as far as the first law is concerned. Then let's move to the second law. The second law, it says that, let's say we have something like this. Let's say we have a raised to the power m divided by what? A raised to the power n. In this case, the first arithmetic operation we have is the multiplication sign, right? In this case, the second is the what? Is the division sign. So let's say we have a raised to the power m divided by a raised to the power n. What's going to be this? I can actually rewrite this as what? As a raised to the power m divided by what? A raised to the power n. Luckily, their base are equal. Since the base are equal, I can simply bring this up so that I can have that what? A raised to the power m minus n, which is the answer. So whenever you have a raised to the power m divided by a raised to the power n, you are going to have to what? A raised to the power m minus n. Suppose you have a raised to the power what? A raised to the power 5, right? Divided by what? A raised to the power 4. This expression is going to be what? That's a raised to the power 5 divided by what? A raised to the power 4, which also is the same as writing a raised to the power 5 minus 4, right? So here we're going to have to what? That's a raised power 1, which is the answer. That's just it about the second law. Then let's move to the third law. The third law now that we have, the third law says that, let's say, suppose we have a raised power m, close the bracket, n. We have m inside and n inside, right? This actually means a raised power what? A raised power m n. That is, you're going to multiply it. You are going to use your m to multiply what? Your n. So here, let's say you have it to be what? A raised power 2 or raised power 3. Then this is simply what? A raised power what? 6. Okay, so that's just it about the what? About the second law. So let's move to what? The fourth law. The fourth law. As far as the first law is concerned, the first law is also known as the law of zero index. Law of zero index. That's the first law. So the first law is saying that whenever we have, let's say we have a raised power m divided by what? A raised power m. What do you notice here? If you look at this case very well, this is actually the same base and also the same power. Then what is this one going to give us? This is actually, the case is actually different from the one that we've been solving. So what it means is that we're going to have it to be what? To be equal a raised power what? M, right? Minus m, right? So this simply is actually a raised power 0, and anything raised power 0 is what? Is 1. So that's law of what? Of zero index. That means if I should have, let me just say you have 2 raised power 0. 2 raised power 0 is also what? 1. A raised power 0 is what? 1. B raised power 0 is equal to C raised power 0 is equal to what? Z raised power 0 is C equals to what? 100 raised power what? 0, which is also equals to what? Equals to 1. That's just what the fourth law is talking about. Then let's simply move to what? To the fifth law. The fifth law is actually the law of negative index, right? So you have to be law of negative index. And negative index is saying that whenever we have a raised power m, then multiply by a raised power minus m, right? This actually equals to a raised power m minus m, which is equals to what? A raised power 0. And anything raised power 0 is equals to what? That's 1. Now suppose we have something like this. Let's say we have a raised power m, right? Then times a raised power m divided by what? A raised power m. If you have anything like this, note this is actually a raised power m multiplied by a raised power m, which is actually equals to what? 1. A raised power minus m rather. A raised power m multiplied by a raised power minus m. This actually equals to a raised power m minus m divided by what? A raised power m, which also equals to what? A raised power 0 divided by a raised power m. This actually equals to 1 over a raised power m. Right? So in this case, we are going to have this. We can write this 1 over a raised power m. We can write it as what? As a raised power minus 1. So this is actually known as what? The law of negative index. So here we have the law of negative index. We can have it to what? Minus m rather. So that's just it. Now let's move to the what? To the sixth law. The sixth law is saying actually the law of fractional index. The law of fractional index is saying that, let's say, suppose we are given a value of a raised power 1 over 2 all squared. Then what is this going to be? Whenever we have this kind of fractional expression, we can express it as what? As root of a all squared. So this cancel this, then we are going to have to what? To be a. Right? So whenever we have something like this, let me just say we have a raised power, that's 1 over 3 all squared. So this actually saves as what? As cube root of cube root of a, right? All this power 3. So this we can actually cancel everything here. So it's still the same as writing a. So whenever you have something like a raised power 1 over 4, all this power 4. This is simply a raised power 1 over 4 times 4. This cancels this, right? So we are going to have to what? To be a. So that's the law of fractional index. So now let's say we are given some question. Let's say we are asked to solve this question. Question 1. We are given the first question to be 5 raised power 6, then multiply by 5 raised power 6 is equal to what? Then the second question, we are given to what? 9 raised power 8 divided by what? 9 raised power 4, right? Is equal to what? Then the third one, we are given 4 raised power 3 raised power 5 is equal to what? Then the fourth question, we are given 8 raised power 0 is equal to what? And also, we are given 90 raised power 0 is equal to what? is equals to what? Sorry, is equals to what? Right? So if you look at this question, the first law is what we are going to actually apply on this. You can simply withdraw that this resemble a raised to power m times a raised to power what? N. Right? Which is equal to what? A raised to power what? M plus n. So in this case, we are going to have to what? That's this a is our 5. 5 raised to power 6 multiplied by 5 raised to power 6. That's actually 5 raised to power what? 6 plus 6. Which is equal to what? 5 raised to power what? 5 raised to power 12. Right? So that's just the answer. Now, what of this? In this case, this is 9 and this is also 9. So you can simply have to what? Whenever we have division, since their base are equal and we have division sign here, so we are going to have to what? 9 raised to power 8 minus 4. So this is actually 9 raised to power what? 4. Right? So that's just it about that one. So what of this one is actually the what? The third law. So in this case, you can just record that whenever we have a raised to power m n, you see same as what? A raised to power what? Mn, right? M into bracket n, right? So we are going to have to what? 4 raised to power 3 times 5. This actually equals to 4 raised to power what? 15. That's just the answer. Then what of this? N raised to power 0 is equals to what? 1. N raised to power 0 is equals to what? Equals to 1. Right? So let's say we are given question 5 now, which is the law of negative index. We are given 6 raised to power minus 3. Right? You know, this actually is the same thing as writing what? 1 over 6 raised to power 3 according to law of negative index. And this is equivalent to what? To 1 over 6 times 6 times 6. Right? Simply this equals to what? 1 over 216. Right? So that's just it. Let's say we have, for the fifth law, let's say we have something like 32 raised to power 1 over 5. Right? So 32 raised to power 1 over 5 is simple as writing 5 root 32. Right? And 5 root 32 simply give us what? That's 2. Right? So let's say we have another one question on that. Let's say we have 27 raised to power 2 over 3. Right? If we have 27 raised to power 2 over 3, this is actually the same thing as writing cube root, right, of 27 all squared. In this case, it is all equals to what? 1. But here it is all squared, right? So, and this is actually cube root of 27 is actually 3, right? And here we have it what? 3 squared, which is what? 9. So if you enjoyed this video, please kindly share it with your friends and give it a thumbs up, right? And don't forget to subscribe to my YouTube channel, please. That's the only way you can help this channel. Thanks for watching.